Hi everyone, welcome to Kia and Hyundai Diagnostics YouTube channel. In this video, I'm gonna explain a starting system on KIA Sportage QL, which is applicable for all KIA Sportage models from 2016 to 2021. So I will explain the starting system wiring diagram, how to read the wiring diagram, how to find the components, which is going to be really helpful for starting system diagnostics. I will show you all the components location, all the connectors, and the pin numbers that you need for performing the diagnostics. And as we may have two different options on this car, one option only with ignition switch when you have a mechanical key, and the second option with start and stop button, with the push button, actually with the smart key system. So I will explain both options as well. I will start with the mechanical key, and right after that one in this video I will explain how to perform diagnostics on a start system if you have a smart key system as well. Okay, let's start. So as you see the wiring diagram right here, all the components for starting system are shown in here. Let's have a look at the components, then we go for reading the wiring diagram itself. So we have the battery right here. Right here we have ER junction box, which is engine room fuse and relay box. So this is the engine room fuse and relay box when we have the starter relay inside. So this is the ignition switch itself. A smart junction block or a smart junction box is actually your interior fuse box. So you have one fuse right here. ICM relay box, which contains burglar alarm relay. In only some cases you may have this one if there is no immobilizer system at all, and you already know that most of the cars they come with immobilizer or a smart key system, so this is not gonna be really common. We have transaxle range switch on the transmission, which plays an important role on a starting system. Right here we have PCM or engine control module or powertrain control module, and then we have starter motor itself. All right, let's start from the beginning. So as everyone knows, for cranking the engine we need to turn the ignition switch to a start position. This is the first thing you normally do for cranking the engine. So this is the ignition switch. Anytime you turn the ignition switch to a start position, you are actually changing this position from here to there. So what happens normally by doing this, you are actually providing this power supply from this pin right to the output to this red wire. So on ignition switch we have one connector, and the connector code is M03, and as you see the input for ignition switch is pin number 1 and the output is pin number 3. And let's have a look at the connector M03 to see where are this pin number 1 and number 3. So this is the location of connector M03 for ignition switch, just right here. And this is the connector details, M03 ignition switch, and these are the pin numbers. This is pin number 1, which is input, and pin number 3, which is output. So it means when you turn the ignition switch to start position, you should have battery voltage in pin number 3, which is the output. If ignition switch is working perfectly, the battery power should be provided to this pin. And then power supply is going to travel from this red wire all the way to a smart junction box, which is your interior fuse box, to reach to this fuse. So this fuse is actually a 7.5 amp fuse. Fuse number is F9, and this is the sign of the fuse if you try to look for it inside the interior fuse box. So if this fuse is okay, is gonna provide the power, is gonna pass the power all the way to pin number 18, which is output. So obviously, if you are not able to crank the engine, checking this fuse would be one of the very first options. And you can verify the ignition switch operation as well by checking this fuse. If you check the power on this fuse, if you see the power is provided at this fuse when you are cranking the engine, so it means the ignition switch is working perfectly and you don't need to go for it. So if fuse is okay, is gonna just pass the power all the way to pin number 18, but it's really important to know where is the location of this pin number 11 and pin number 18, just in case if you want to check it out. So on this car, pin number 18 is on IPE connector and pin number 18 is on IPF connector. So both of these connectors are on a smart junction box. Let's have a look at the connector locations. So here is the connector location IPE, just right here, and IPF right here. So these are the location for those connectors. So if your car is right-hand drive, you can just find the location right here, IPF and IPE on smart junction box. And details for IPE, if you remember, pin number 11 was input to that fuse box for a starting system, which is right here on IPE. And for connector IPF, as you see here, pin number 18 was output from the fuse box, which is just right here, pin number 18, yellow and orange wire, which is output from the fuse. You see the pin number 18 just right here at the top. All right, what happens after power left the fuse box? So now it's actually based on two different options. So in case that car doesn't have immobilizer system, the safety feature is burglar alarm system or burglar alarm relay, which is inside the ICM relay box. So this is the location of ICM relay box, just in case you need that. But as I said earlier, most likely your car has either immobilizer system or smart key system, so most of the time you're not going to need this section of the wiring diagram. So power supply will travel all the way from here to transaxle range switch, and transaxle range switch is a feature on a car with automatic transmission to prevent the engine from cranking if transmission is on drive or reverse. So you are only able to crank the engine when transmission is on park and neutral. I believe you already know that, and this will happen by transaxle range switch. So the input to the transaxle range switch is this wire, green orange wire, to pin number 1 of connector C301, and the output is pin number 2 of the same connector. Let's have a look at the location of transaxle range switch, which is on over the transmission, and then we will have a look at the pin number 1 input and pin number 2 output of the transaxle range switch. So here is the location of transaxle range switch connector C301, just right here. And this is the connector details. As you know, pin number 1 is the input, just right here, and pin number 2 next to that is the output of this range switch. So normally if you check the output, you should have the battery positive voltage if you are cranking. So when you are cranking, you should have the battery positive voltage right here at pin number 2. So what happens after that? If transaxle range switch is working properly, it's going to send the power supply from here toward the starter relay, and at the same time we have the battery voltage sent to the PCM. So PCM received this one, to be informed that you are trying to crank the engine. So accordingly, PCM is going to provide the ground for starter relay. So this is the first thing that PCM is going to do. So this battery positive will travel all the way from here to starter relay. So starter relay has the battery positive from this pink wire or pin number 5, and from terminal 3 it will receive the ground from the PCM. So if these two are provided, relay will be energized, and by energizing the relay, we create enough magnetic field to close the switch inside the relay, and then battery positive will travel all the way from here, from this switch inside the relay, to starter solenoid. And what happens when a starter solenoid receives this battery positive, it does have the negative on the body, so it will create enough magnetic field to pull the plunger in, to engage the starter motor pinion, and to provide the high current battery voltage to starter motor to drive it. But there are some other important point in here as well. First of all, what is this ISG? It's idle stop and go function on Kia and Hyundai. So normally when you do very short stop at the light or in any other occasions, if your car has ISG function, PCM is going to turn the engine off, and right after releasing the brake, when you push the gas pedal, PCM will start the car automatically, and obviously you're not going to need to start the car manually. So if car has this option, you will have this section as well to start the engine automatically. And if you notice in here, between the starter relay and the starter motor, you have one connector which is named CB31. This connector has only one pin between these two. It can be used for important troubleshooting. If you try to energize the starter to make sure if the starting system works perfectly or not, you can provide the battery positive from here. Let's have a look at the location. So this is CB31, just right here, which is between the fuse box and starter. So as you see, this connector has only one pin. So it's really important to know actually the location of this connector, because sometimes your starter relay works, but you see that starter solenoid doesn't receive any battery positive. So if your relay is working properly, relay itself is okay, and starter solenoid doesn't receive any signal, so the problem could be from this one pin connector, which obviously should be inspected accordingly. But if your car has a smart key system or push button start system, there are some significant differences between these two. So first of all, obviously you don't have ignition switch anymore. You have push button start just right here. So when you press the push button start, what happens? There are two switches inside, which these two switches are going to send the signal to a smart key control module. And the reason that we have two switches inside the start and stop button, because if one of them goes faulty, the other one will be working, so everything will be working as normal. So a smart key control module is right here. These two signals will be sent to SSB SW1 and SSB SW2. So you can check these two signals one by one, or if you have a scan tool, you can connect the scan tool, and in live data you can find the relevant data for these two, and anytime you press the start button, you see the signal inside the scan tool. So a smart key control module, as soon as it gets the signal from these two wires, is going to send the start relay output from here to energize the relay. So what happens, you have this connector M16C, which accommodate all these pins inside. So I'm going to show you the location of M16C and location of the Smarty control module, and you see all the pin numbers in case that you're going to need to check them. So this is the location of a Smarty control module under the dash. There are 3 connectors on the Smarty control module. This is what we are after, M16C, just right here on the Smarty control module. And this is the connector details. So all those pin numbers, they are just right here. So you have pin number 3 and 13. Pin number 3 is SSB1 and pin number 13 is SSB SW2. And you have all other details just in case if you need that. You can just have a look at these pin numbers for further troubleshooting. Okay, as I said earlier, as soon as the smart key control module receives the signal from SW1 and SW2, is gonna provide the output for energizing the relay from here, from pin number 10 through this red wire. And as we see right here, this red wire is going to travel all the way again to a smart junction box, which contains F9 7.5 amp fuse for a starting system. So again, same sign for the starter fuse. And if fuse is okay, it's going to travel from here from IPF pin 18, similar to the previous case, to transaxle range switch. Again, pin number 1 is the input, pin number 2 is the output, and then we have this joint connector. So this joint connector, first of all, is going to send one signal back to the Smarty control module, which is a start relay feedback. So this is actually to ensure that this wiring from here to the fuse and transaxle range switch and this part of the wiring is okay. So if wire is damaged, if there is any short to ground, if one of these components is faulty, and if this signal is not received to Smarty control module, what happens? A Smarty control module will cut this power which will cut this power to a start relay, just to make sure if there is any failure, this failure is not gonna damage the wiring or other components more. But if this signal is received to a Smarty control module normally, obviously system will be working normally as well, and this battery positive will travel from here through this pink wire to a starter relay, and negative is provided from PCM, exactly like the previous wind diagram. We have ISG options as well. If you don't have ISG, the power to the relay will be provided from here. If you do have the ISG, PCM is responsible to energize the starter relay. The rest is exactly the same. When a starter relay receives a battery positive from here and negative from the PCM, it will be energized to close the switch and to provide this battery positive to start solenoid. And as you guys know, on a starter solenoid, we have 3 terminals. One is S terminal, which receives the battery positive from a starter relay. So this one is going to energize the start solenoid, and we have B terminal, which gets the high current voltage from battery, and we have M terminal to pass the power from solenoid to starter itself. And as you see inside the diagram, these 2 windings, they are actually pull in and hold in winding inside the starter solenoid, as you have that one in all other starting system as well. So I hope this wind diagram analysis helps you guys to perform the diagnostics on a starting system on KIA Sportage QL 2016 to 2021. We will try to make many other videos for other systems and different models on Kia and Hyundai as well, because most of the time if there is any electrical failure you're gonna need all these details to be able to inspect the car and to fix the car. Thank you very much for watching. If you like the video, please don't forget to share it with your friends and press the like button.